If you've shopped for a router recently, you've undoubtedly seen the term beamforming being thrown around. Beamforming is a feature of newer routers, and in the marketing material that you read, you'll see that it promises fast and smooth Wi-Fi connections with the devices in your home. This is all well and good and promises are great, but this is something that I wanted to put to the test. So in this episode from Network from Home, I'm going to be explaining to you the concept of beamforming and how it's supposed to work. And I'll also detail an experiment I ran just to see how effective beamforming truly is. In terms of what beamforming is a technology that allows your router to identify where devices are located and actually steer your Wi-Fi signals to that device. This results in a better Wi-Fi signal for your devices, and in turn, it provides a faster Wi-Fi speed as well. So with previous versions of routers, you had to manually steer your Wi-Fi signal by changing the configuration of the antennas. This is something I detailed in a previous video, but with a beamforming router, you don't have to do any of that. Your router will automatically steer your Wi-Fi signal for you in the direction of your devices. So how does a beamforming router actually achieve this? Well, a beamforming router actually starts off by following the model of a non-beamforming router. It starts by casting a wide net of Wi-Fi signals in all directions from its antennas, and then once it starts to communicate with a particular device, it will calculate where that device is coming from, the direction it's communicating from, and then it will actually take those broad Wi-Fi signals and it will narrow them down in the direction of that particular device. This results in a longer range of Wi-Fi signals because all of the antennas of your router are working together. And on top of that, it also ensures that there's less interference with other devices that might be nearby. By narrowing down that Wi-Fi spectrum, that Wi-Fi tunnel, it's focusing directly on the device it's communicating with. It's providing it with a strong signal and also a fast Wi-Fi speed as well. I won't get into the specifics too much here, but the fact that your router has multiple antennas, that's how your router can calculate where a device is located. Based upon the signals that it's receiving from the device, it can actually calculate the distance from each individual antenna, and based upon that distance, it can determine the direction where that device is communicating from. If this might be a little confusing for you still, I've come up with an analogy I think that will help you understand this much better. In this analogy, let's pretend that we have a dog. And this dog, unfortunately, has run off at night. It's run into the woods and we need to go and try to find it. So here we have our dog. The dog is in the woods amongst the other animals, the bushes and the trees. And it's our job to use our flashlight to find our dog. In this first part of the analogy, let's take it from the perspective of having a router that's a non-beamforming router. In this example, we go into the woods, we turn on our flashlight, and our flashlight shines a wide ray of light. We try to use this wide ray of light to find our dog, but as you can see here in this picture, there are other things that might distract us. This fox might distract us, this deer might come into the ray of light. Any movement is going to point us in that direction, and we're going to want to see if that's our dog. Even with our dog calling out to us and barking, we can turn the flashlight, as you can see here, and we can face the dog and see if we can see it through that ray of light. But what you'll notice is that there are still obstructions here. The fox is in the way, the bushes and trees are in the way, and in this example right here, the dog is still out of the range of light. So in order to find your dog, you really need to get closer. Taking this back to a non-beamforming router, with a non-beamforming router, you have opportunities for interference because you're broadcasting these Wi-Fi signals in all directions. So if you are communicating with a device from your non-beamforming router, if another device gets in the way or there's an obstruction, it can impact the Wi-Fi signal and Wi-Fi speed of that device. Also, as you can see, the range of the Wi-Fi signal is a bit limited because the Wi-Fi signal is being broadcast equally in all directions. Now let's jump over to the second part of the analogy where we have a beamforming router. So in this case, we start the same way as the non-beamforming router. We have this wide ray of light that's being broadcast in an attempt to find our dog. In this example, our dog starts barking and communicating with us. So then what we can do is we can take that flashlight, we can narrow that ray down in the direction of the sound of your dog barking. And as you can see here, we're able to really shine that light directly on our dog. There are less opportunities for interference because of that more narrow signal. And as you can see, that ray of light extends farther because it's more concentrated. It's not this wide ray of light that's broadcast in all directions equally. It's really concentrated on the direction of the dog barking and the direction of where we think the animal is. This is the same case with how beamforming is supposed to work. Once you start communicating with a device, your router is supposed to concentrate those Wi-Fi signals in that direction. It provides less opportunity for interference from other devices. It also provides a longer range, a longer Wi-Fi signal range in that direction because all of your antennas are working together to send a Wi-Fi signal in that concentrated direction. Hopefully that gives you a good understanding of how beamforming works and what it's supposed to do. And here's where things get really interesting. In order to see if beamforming actually gives the boost that the marketing material says it does, I designed a little experiment to test out its effects. In this experiment, I identified 2 locations in my home, one location close to where my router is located, another location far away from where my router is located. I then took a non-beamforming router, and I also took a beamforming router, and I measured the Wi-Fi signal strength of my devices in each of these 2 locations for both the non-beamforming and beamforming router. I wanted to see if the beamforming router truly provided a stronger Wi-Fi signal and also faster Wi-Fi speeds for my devices in these locations. The first thing we'll look at here is the Wi-Fi signal strength of my devices with these 2 different routers. The first location is far away from my router. What's important to note here is the Wi-Fi signal strength is from 0 to -100, -100 being a really poor Wi-Fi signal and 0 being a fantastic Wi-Fi signal. As you can see here, the Wi-Fi signal strength is pretty similar for both the 2G and the 5G networks for the devices that are far away from my router. This isn't exactly what I anticipated because with beamforming, I expected a much stronger Wi-Fi signal. As you can see here, beamforming with 2G had a little bit stronger Wi-Fi signal, but with 5G, there really wasn't much of a difference. When I took readings again close to my router, the results weren't really that different. Both the 2G and 5G networks had about the same Wi-Fi signal strength for a beamforming and non-beamforming router. At this point, things were not looking great for the beamforming router, but here's where things changed a little bit is when I started measuring the Wi-Fi speed at these different locations. Starting at the location far from my router with the 2G Wi-Fi network, we saw exponentially faster Wi-Fi speeds. With a non-beamforming router, I was seeing 0.5 megabit per second. With a beamforming router on a 2G network, I was seeing 8.5 megabits per second. That's significantly faster Wi-Fi speeds. So there it looks like we got a lift from beamforming. The same can be said with the 5G Wi-Fi network when comparing the beamforming and non-beamforming router. The difference just wasn't as great as with the 2G network. Okay, so things are starting to look a little bit better here. How about the location close to my router? At the location close to my router, there was improvement with a beamforming versus non-beamforming router, but the differences weren't as significant as at the location far away from my router. And if you think about it, this makes sense because if we remember what beamforming does, it actually extends your Wi-Fi signal in the direction of the devices that are communicating with the device. Therefore, devices that are maybe on the edge of the Wi-Fi signal range with a non-beamforming router should have a much better signal with a beamforming router with a concentrated Wi-Fi signal. So all in all, can we say that beamforming improves your Wi-Fi signal strength and Wi-Fi speed? Wi-Fi signal strength, maybe not so much in my experience, but with Wi-Fi speed, we can say definitively, yes, a beamforming router provides faster Wi-Fi speeds to your devices. So although the results of this beamforming experiment might not be super impressive, I know I wasn't really impressed. The bottom line is there are still likely brighter horizons in the future as they continue to develop this feature. If you have any questions about this experiment or about beamforming, please drop a comment below. If you found this video useful or interesting, please give it a like so that way it gets shared with other people. And lastly, if you find the content that I'm presenting on my channel either interesting, helpful, or funny, please subscribe to the channel. I'll be happy to have you join along for the ride as I continue to put out more content in the future. As always, thanks for checking out this episode from Network from Home, and we'll catch you on the next one.